Problem number 1 from the 1.5 topic questions. You have looked at the prompt, you've read it, I've recreated the schematic, and I'm going to restate what they're asking you to find. Boat crossing a river that's flowing. Dimensions of the river given, both horizontally and a vertical distance that describes where the boat, how far upstream the boat has landed. The prompt says find D, and then they give you some choices. The choices, in effect, are equivalent to asking you to find D in terms of all these other variables. Okay, and I use capital BW instead of lowercase, just because I write that way. All right, how do we solve this? Well, the first thing is some clues. You've seen a system like this: boats in water, airplane moving through wind. But I think the big kicker here, or the big hint, is the VW, right? There's a VW right there. That's already should strike you as relative motion. So it's the velocity of the boat relative to the water. The water is flowing at velocity VR, okay? And since that should clue you into relative motion already, hopefully the physical description, not just the symbols. But relative motion, so that means I've got an equation for that. I know that the velocity of something moving in a fixed frame of reference is equal to the velocity of that same thing relative to another thing that's moving, plus the velocity of that other thing that's moving relative to the same fixed frame of reference, or reference point, or a fixed observer. The g is the thing that's not going to have a velocity, zero velocity. I've got a VBW. Both are moving, so that's got to be this guy. So I go, that's going to be my VBW, which sets up my other subscripts. This A is my boat. So this A is my boat, ground. This B is my water. So this B is water, G. So I have applied this math model, the relative motion math model, to my system, but it doesn't quite match symbolically everywhere, right? For example, there's no velocity of the boat relative to the ground depicted anywhere here as a velocity vector. This is depicted in the picture, but what is this guy? WG, water relative to the ground. Well, if that's in my system, what could it be? It has to be the velocity of the river. Because what's a river? It's water moving, and if I see water and it's flowing, I go, it's 10 miles per hour east. Well, 10 miles per hour relative to what? It's got to be the shore, an observer standing on the shore. Somebody's on the shore not moving. So that VWG must be this VR. And notice that it's only flowing up and down, right? Vertical. Well, that means anytime I look at my options, or if I look at this, what I'm really looking for is that this could be, or this is the velocity of the water relative to the ground. Okay. Next thing. So we have, in other words, we have an equation set up. We've translated the physical system that we're looking at into. This is a math model of all the velocities. Well, what about the math model for everything else? Because we're going to stay math. Why? Because D, the choices are in terms of, and it's a mathematical expression. If it was a conceptual problem where I had words to choose from, maybe I wouldn't have jumped right to this. But seeing the choices, for a good place to start would be the math. Okay. What about W and D? Well, D is how long the boat takes to move in a vertical space, right, in a vertical dimension. But that space is on the ground, or it's measured on the ground. So which velocity of the boat applies? The velocity of the boat relative to the ground. That's probably the biggest, or that's a key understanding or conclusion for this problem, because you've got two velocities involving the boat. If it's not clear to you that to go as the boat travels across, if it covers this space that's fixed, if you're not sure why that's this velocity that's related, let me know. Okay? Actually, I'm going to write out something. I'll write it out real quick. Okay? So D is basically corresponds to a vertical displacement, right? A change in my y position. The W corresponds to a delta x, or horizontal displacement. Well, doesn't a change in y, since it's on the ground, that corresponds to, or is, how far I go up, depends on or corresponds to the velocity of the along that dimension or in that space. But that space is on the ground. The space isn't moving. It's fixed. So it's really the velocity of the boat relative to the ground in the y direction. On this one, that delta x, which is really w, right? So those are talking about the same physical quantity, a change in my vertical position. This is talking about the same thing, a change in my horizontal position. But that delta x also corresponds to what? It corresponds to how fast I'm moving in the x direction relative to that space, which is the ground. I mean, it's relative to the shore. The w is, it's a space that's not moving, changing because of motion or anything like that. For example, it's not the space between two things that are moving, right? It's not that thing, okay? So how long it takes me to do that is I basically cover this space in the same amount of time as I cover this space, because I'm crossing the river, right? So even though I'm moving like this, it's as if I'm doing this, okay? So this I'm doing that. Okay, so I need to find VBGY and VBX because this corresponds to that, and that corresponds to that. Well, what are those things? Aha, X and Y. Well, so would that have occurred to you? Hopefully, because you know that this is velocity, and the W's and the D's are perpendicular dimensions. So X's and Y's hopefully occurred to you. Well, I'm just going to write the X and Y version of this thing. So in the X direction, now I'm going to remove the vector arrows. I could keep them, but I'm just going to simplify it, and I'm going to remind myself that positive is to the right. So mathematically, as I do math in the X dimension, if I come up with positives or negatives, they represent direction, okay? And that way I don't have to keep writing the arrows. Okay, or thinking about the arrows. I've got VBG in the X direction, which could be positive or negative as an answer, and that's what that means. Okay, positive or negative. All that is going to equal what? VBW in the X direction plus VWG in the X direction. Oops. VWG in the X direction. Let's set up the Y's. Y's positive up. I can make it down, doesn't matter. I'm just going to be consistent, okay? I'm going to go positive up. So VBG in the Y direction, that's got to equal VBW in the Y direction plus VWG in the Y direction. When in doubt, write something, okay? Keeps your brain moving. If you try to tackle this all conceptually, chances are very good, though certainly not, absolute. Chances are very good that you're just going to lose track of your thought process and what the arrows are and what the quantities were. Just keep track of everything, okay? If you change your mind, you find out you're wrong, you can always just draw a line through it or erase it if you're working in pencil. Okay, so let's apply what we know to this math model. VBGX. that's going to be the velocity of the boat relative to the water. I've got the velocity of the boat relative to water. But in the x direction, that's just going to be VBW cosine theta. BW. I'm going to drop the BWs. I'm just going to keep that. Okay. So that's cosine theta right there. Plus, oh, this is nice. What's the velocity of the water relative to the ground in the x direction? 0, because it's only flowing this way, right? So that's 0. That's got to be my velocity of the boat relative to the ground in the x direction. What about this one? I've got the velocity of the boat in the y direction there. Let me just write this out. That's the y component of this vector. So that's going to be VBW sine theta plus the velocity of the water relative to the ground in the y direction. The water is going down. So I'm going to say minus V. And now I go, well, wait a minute. All the WGs are kind of, this one disappeared. I don't really need that to hang on to what that is, right? So I'm just going to say, well, what's VGY? Oh, if VGWX is 0, then this VR is exactly the same as VWGY, so I'm just going to replace that with R. Okay. So what is, how long does it take to, well, let's see. My X is what? I travel W in a certain amount of time, and that's based on VBW cosine theta. The distance I travel depends on VBW sine theta minus VR. They also take the same amount of time, right? So if we remember our time models or our basic kinematics, right? A velocity is equal to a displacement in the x direction divided by time. So how far I go time-wise, I can just multiply both sides by t, and I get that. Or likewise, I must have done this in the same amount of time. Whoops, that was correct. So if this is constant velocity, so I'm not going to worry about the average velocity. It's constant, so the v doesn't change. That also means that the amount of time it takes to cross is equal to that displacement divided by v. Okay, so the other thing that we need to note here is that the time it takes to go w at this speed, right, at that speed, I'm moving this way at that speed, I traverse w meters. In the same amount of that same amount of time, I traverse a distance d at this speed. So if we remember this, what's the same? The time it takes to travel w is the time it takes to travel d. So I'm going to remind myself that the time to travel w is equal to the time to travel d. And each of those times is that distance divided by their velocities. So if those are the same, we also know the following. We know that VBGX, should start with W, right? Looking at this, we know that I would have had to go W distance divided by how fast I was going in that distance, or in that direction, sorry. That time has to equal this divided by VBGY. That means my distance d is actually equal to w times, if you do the algebra, VBGY all over VBGX. And you have enough information now to get the final answer. So I will declare this problem home free. You're home free. You're just got these substitutions, and then you should see there should be the answer should be the answer. Right? And that is number 1, topic question 1.5. Or the 1.5 topic question is number 1.